Greetings, math fans. All right, so this is day 4 of our chapter for systems of equations. And so basically what we're going to do now is we're going to do some applications, how you can apply systems of equations to real life problems. Okay? All right, so let's just start out. There are 3 kinds of problems here, math fans, 3 kinds of problems. And we're going to do all 3 of them, and then we're going to practice them again. Okay, just so you guys are good to go with this. All right, very important. Got to know how to do all 3 of these for your quiz, for your test, for your final exam. They may even show up on an SAT question. Never know. Okay, so let's do it here. It says, set up a systems of equations and solve. So here's the deal. I'm going to highlight this. It says set up a systems of equations and then solve. So some of you guys might have the thought of, I'm just going to do it without systems. I'm just going to kind of think logically about it. That's great that you can do that. But I'm looking for that you set up a system. If you don't set up a system, I'm not going to give you any credit for it. Okay? You got to set something up for me, solve it, and then give me the answer. Okay? All right, so let's take a look at this. It says the sum of 2 numbers. What does the word sum mean? Sum means add. So 2 numbers, I'm going to call those x and y. So I'm going to say x plus y is equal to 28. Okay, it's pretty easy. That's sum. So sum is add. And then their difference, so what does difference mean to math? Well, it means subtract. Okay, so the difference is 6. So watch this. X minus y equals 6. What are the numbers? So this is it, man. X plus y is equal to 28 and x minus y is equal to 6. This is like a super easy systems of equations because the y is already set up to cancel. All right, so basically that cancels, and then you wind up with 2x. And I'm going to tell you, math fans, that is the #1 mistake that people do that I've noticed on quizzes is you have this and people just say x equals. They don't say 2x. Super important. If you just say x equals, it's wrong. Okay, it's 2x because x plus x is 2x. And then 28 plus 6 is 34. We solve by dividing by 2, and we get x is equal to 17. And then how do you find y? Plug it back into one of the other equations. So we'll plug it back into the first one. So it's x plus y, so x plus y is equal to 28. And then we solve for y. Subtract 17, so y is equal to 11. And there you go. Those are your 2 numbers, 17 and 11. That's it. That's all you do. Really, really pretty easy, guys. Okay? Okay, so let's cursor down here. The next one. It says a mini auditorium can hold 61 people. Tickets to a math concert, ooh, that sounds exciting, costs $4 for adults and $3 for students. A total of $224 was collected. How many adult tickets were sold? So here's the deal. You need to set up two variables, okay? So I'm going to say x equals the number of adult tickets. And y equals the number of student tickets. So sometimes people say the variables are x is the cost of an adult ticket and y is the cost of a student ticket. I already know that. Adults cost $4 and students are cost $3. So I don't need to set that equal. I don't need to find out how much each cost. I know what they cost. I want to know how much or how many tickets were actually sold. Okay, so I call this a cost quantity problem. Okay, so when I say, well, let's do quantity first. That's actually the easiest. If x is the number of adult tickets and y is the number of student tickets, and there were 61 people in the auditorium, the setup then is x plus y equals 61. That's the first equation. Okay, that's easy. That's the total number of people. Okay, the next thing is this. It's $4 for adults and $3 for students, and I collected $224. So the next equation is going to be this. It's $4 times the number of adults, so $4 times the number of adults plus $3 times the number of students. Right, if I multiply all that out and add it together, I should get our total of $224. That's the setup for that. Okay, if you can't get that set up, you're not going to get this problem. Okay, so again, it's the quantity. It's always x plus y equals the number of people. And the cost is always the cost per ticket, like for the adults, times the number of adult tickets plus the cost for a student times the number of student tickets is equal to that total, which in this case was 224. And now you're basically going to use you can use your calculator to figure this out, but we obviously got a systems here, so we're going to multiply this one by, I'm going to multiply it by -3. Now you could multiply it by -4, and that would give you the correct answer as well, but then you're going to start with dealing with negative numbers. If you pick the smaller number, it's usually helpful because then all your numbers stay positive, and that's kind of nice. Okay? All right, so I'm kind of running short on room here, but I'm going to write this out now. It's -3x minus 3y is equal to -3 times 61 is -183. And then I'm going to write 4x plus 3y is equal to 224. Okay, so the y's cancel, which they should, and you get -3x plus 4x is positive 1x, which is nice because it's already solved. So you get 1x equals 41. Put it in your calculator. So I'm actually done with the problem, guys, because I'm asking you how many adult tickets were sold. And that's what x is, the number of adult tickets. So there we go, 41 tickets. Okay, 41 tickets. Now if I ask you the number of student tickets, you just plug it back into, I don't know, plug it back into this guy right here. X plus y equals 61. So I would do that. X plus y equals 61. Subtract 41 from both sides. So y is equal to 20, which y, remember, was the number of student tickets. And so that would be 20 tickets for students. Okay? Pretty easy. Okay, so that's the second kind of problem. The third kind of problem is a rectangle problem. Okay? So basically, you have, this is the length of a rectangle is 8 units larger than the width. So think about it. Length is an equal to sign. 8 units larger than the width. So 8 units larger than the width. So 8 plus w. Okay? And actually, the way I really like to write it, I'm going to erase this. The reason I like to write it this way. And I'm going to tell you why in a second. So length equals w plus 8. And you're like, Mr. Kurtz, what's the difference between 8 plus w and w plus 8? Well, if I said something is larger, you're going to say w plus 8. If I say it's smaller, I want you to write w minus 8. Because if you write 8 minus w, you're going to get it wrong. Okay? So L is equal to w plus 8. Doesn't really matter here, but no big deal. All right, so that's the first part. The perimeter. You guys remember when you have a perimeter of a rectangle, you have a width, and you have a width, and you have a length and a length. And remember, perimeter is distance around. So it's 2 L's, 2 times the length, plus 2 times the width is equal to 32. So guys, this is always the case. This will always be 2L plus 2W equals the perimeter, which is in this case 32. Okay, always, always, always. That's 2L plus 2W. Always, always, always. And then this one is not really always, always, but its length equals, in our case, we're going to be W plus something. 10 units larger, W plus 10. 3 units larger, L is equal to W plus 3. Okay? So, let me get rid of this. There we go. That, and let me just actually write the equation out here. So length equals W plus 8, and 2L plus 2W is equal to 32. Okay, so what are you going to use? You're going to use substitution. Right? So it's 2 times L, which is W plus 8, plus 2W equals 32. Okay, and then we just solve. So we get 2W, we distribute that, 2W plus 16 plus 2W equals 32. And so we get 4W plus 16 is equal to 32. And then we're just solving. So subtract 16 from both sides. So 4W equals 16 and divide by 4. W is equal to 4. All right, that's cool. And how do you find L? Put it back right into there. So L is equal to 4 plus 8. So L is equal to 12. And there we go. The length is 12 and the width is 4. And that's it. Okay? It's not bad. All right, let's do a practice of each one of these now. All right, so if I go switch over to number 4, it says the sum of two numbers is 32. Okay, so let's set up x plus y equals 32. Their difference is 14. X minus y equals 14. What are the numbers? Okay, easy systems. The y's cancel. We have 2x is equal to 46 divided by 2. X equals 23. Okay, that's the first number. Plug it back into the first equation. X plus y, let's write this out here, equals 32. So x is 23 plus y equals 32. Subtract 23 from both sides. So y is equal to 9. So here we go. Those are your two numbers, 23 and 9. Super easy. Okay. Let's move on to the next one. Same kind of problem. Mini auditorium holds 30 people. Tickets to the math concert cost $7 for adults, $2 for students. A total of $105 was collected. How many adult tickets were sold? Again, X, so I'd like you to write that down. X is the number of adult tickets, or the number of adults. And Y is the number of student tickets. Okay? So the first one is going to be X plus Y. The number of people are 30. And $7 for an adult plus $2 for a student is going to be $105. There's our equations, man. That's it. So let's get rid of the y. It's a smaller number. I told you that's better. You get no negatives, so I multiply that by -2. So let me write it out here on top. Negative 2x minus 2y is equal to -60. And 7x plus 2y is equal to 105. Okay, so this gives us 5x. The y's cancel. And this gives us 45. Okay, so we divide by 5. X equals 9. There we go. We're done with the problem, actually. It says how many adult tickets were sold? 9. So 9 adult tickets. And again, if I wanted to find out the number of student tickets, I plug it back into that x plus y equals 30. So x plus y equals 30. So plug in the 9. So 9 plus y equals 30. Subtract 9. Y is equal to 21. Okay, so 21 student tickets. Okay, not bad. Let's do the last one here. Length of a rectangle is 6 units larger than the width. Length is W plus 6. 6 units larger than the width. The perimeter is 32. 2L plus 2W equals 32. There's your setup, guys. It's really pretty easy. Substitute that L into there, so it's 2 times L, which is W plus 6, plus 2W is equal to 32. Okay, solve, so we distribute that. Make sure you do that correctly. 2W plus 12 plus 2W equals 32. So 2W and 2W is 4W plus 12 equals 32. Subtract 12 from both sides. 4W equals 20. Divide by 4. So W is 5. So the width is 5, and that means the length is W plus 6, or 5 plus 6. So the length is 11. And there we go. We're done. Okay? You can always check it. And here's a good way to check it. If the width was 5, put the width on both of them, and the length is 11, that all should add up to 32. So 5 plus 11, 16, another 5 is 21, and another 11 is 32, and we're good to go. So these check out. Okay? So that's it, math fans. Really not that bad, but those are 3 kinds of application problems that you need to know for this chapter. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.